Okay, so this is the screencast that I'd like you to watch second. So if you didn't watch the other one, please watch that one first. And this is just a little bit more follow-up. So if you have a concentration of hydrogen ion, and again, brackets mean concentration, of 0.001, technically the units are molarity, but we're not going to really worry about that in pH. And I asked you which one of these is a smaller quantity. Hopefully it's pretty obvious to note that this last one is the smallest, right? So this is the smallest. And then the top one would be the largest in this grouping. Okay, so that's pretty easy to see. But the next step, what I'd like to do is write this into scientific notation. So you might want to pause the video and just do this on your own, just to refresh your memory on scientific notation. So the first one, and I'm just going to put 1.0 because there's two significant figures here. I'm going to keep two significant figures. And then you move the decimal place over 1, 2, 3 times, so that's 10 to the negative 3. The next one is 1.0 times 10 to the negative 4. And then the last one is 1.0 times 10 to the negative 5th. So the only thing that's confusing about a negative exponent is we're used to numbers being like 5 is bigger than 3. But remember, negative 5 is smaller than negative 3. So just keep in mind, this is still the smallest number, right? We're just writing it in a different way. So instead of chemists dealing with, a molarity of 10 to the negative 4 or 10 to the negative 5 or 0.0082341, what they've developed is the pH scale. So before I go into the equation, the pH scale, as many of you know, starts at 0 and goes to 14. It actually kind of is beyond that, but that's beyond the scope of this course. 7 is neutral. And less than 7, anywhere between 0 and 7 are acids, and anywhere between 7 and 14 would be bases, right? Bases have high pH, acids have low pH. Okay, so let's go back to this equation. So if you have the pH equation, and again, you might have been like, logs, Okay, don't worry about it. It's not going to be too bad. And you have your graphing calculator with you, and if you don't, pause it and grab it. And then if you see, right here is a log button. So for the first one, let's go back up here. What I'd like you to do is I'd like you to press the negative button, which is on the bottom, press the log button, which I showed you, and you'll see an open parenthesis, and then just type in 0.0010, close the parenthesis, and press enter. And when you do that, hopefully, you end up with 3. So the pH of the first one is 3, and if you do that with the others, you'll see that the pH is 4 and the pH is 5. So it's much easier for chemists to deal with 3, 4, and 5 than 1.0 times 10 to the negative 3 and so forth. So that's why the pH scale was developed. So the thing that you have to just keep in mind is, again, the lower the hydrogen ion concentration, the higher the pH. So that's what the negative log does. It kind of inverses it. So the lower the pH, the higher the hydrogen ion concentration. So just to summarize, and again, this is on the other screencast, if your hydrogen ion concentration increases by 10, meaning you're getting more acidic, right, your pH will go down by 1. If your hydrogen ion concentration goes down by 10, right? That means you're getting less acidic because you're losing hydrogen ion concentration. In terms of the pH scale, you're going up, right? You're becoming more basic. So that means the pH is going to go up by 1. Okay, and then vice versa, right? So if your hydrogen ion concentration, let's actually take this to 100 now. So if your hydrogen ion concentration goes up by 100, so think about it, you're getting more acidic, right? So your pH is going to have to go down, and your pH is going to go down by 2 because it's a log scale. Same idea here. If your hydrogen ion concentration goes down, you're becoming less acidic, more basic, so therefore your pH is going to go up where the bases are by 2. Okay, so hopefully that helps. And again, there's a screencast, or I'm sorry, there's a Google Meet today at 11, or you can email me if you need any more help.